Hello everyone, welcome to Shivam's classes. In today's lecture, we are going to discuss miscellaneous exercise from chapter number 3, which is part of trigonometric functions chapter. We have already discussed quite a few problems from this chapter, but in miscellaneous exercise, there will be combination of concepts which will be used. So we need to remember all the concepts which we have learned in the chapter so far. Alright, so yeah, before jumping onto the problems, let's revise some of the concepts which we have learned earlier. So the very first thing which we had done was to remember in which quadrant which quantity would be positive. So all will be positive in the first one, sine will be positive, sine and basically cosec would be positive here, tan and cot would be positive here, cos and sec would be positive here. So we remember using this add sugar to coffee, right? And using this, you remember in which quadrant what quantity is positive. The second thing, or rather second bulk of concept is we need to remember what is cos of pi minus theta, what is sine of pi minus theta, what would be my say tan of pi by 2 minus theta, and so on and so forth, right? So these things we need to remember. We also need to remember some of the formulas which we have learned. So for example, we need to remember what is my cos a plus b. So my cos a plus b would be cos a into cos b, right, minus sin a into sin b. Similarly, we need to remember what is going to be my 2 cos a cos b, and in that instance it would be cos of a plus b plus cos of a minus b. Alright, so this is something which we need to remember. We also need to remember something like cos of c plus cos of d. So I'm just talking about the equations in this category. So this category is 1, this category is 1. So you need to remember sine as well, cos as well, here as well. What if it is 2 sine a sine b, or what if it is 2 sine a cos b, and stuff like that. So cos c plus cos d, this is another variety wherein you know that it's gonna be 2 cos of c plus d by 2 into cos of c minus d by 2. Alright, so these are the formulae which you need to remember. I cannot write all of these formulae over here, and you can refer the summary of the chapter to just have a look at all the formulae. So let's start with the first example. In the very first example, we have been given an expression and then we are asked to prove it to be equal to 0. So we'll start with this. We have something called 2 cos of pi by 13 into cos of 9 pi by 13 plus cos of 3 pi by 13 plus cos of 5 pi by 13. So when you look at this thing closely, you know that this is kind of a formula which is like 2 cos a cos b, and in that instance you know that this is nothing but cos of a plus b. Cos of a plus b would be pi by 13 plus 9 pi by 13, and then plus cos of a minus b, which is pi by 13 minus 9 pi by 13. So we had just noted down this formula over here. You remember 2 cos of a into cos b is cos of a plus b plus cos of a minus b. Alright, so this is what it is. And then you have got cos of 3 pi by 13, and then lastly you have got cos of 5 pi by 13. Alright, now look at this. You have got pi by 13 plus 9 pi by 13, and when you sum it up you will get cos of 10 pi by 13, and here you will get cos of pi by 13 minus 9 pi by 13. So you will get cos of minus 8 pi by 13, right? Because minus 9 pi is in negative and this is in positive. And then finally this one cos 3 pi by 13, and then you have cos 5 pi by 13. These two terms I'm just writing down again and again. Now look at this cos 10 pi by 13 very closely. You know that we need to get this expression to 0. So something needs to be done around here so that either something gets cancelled out or we are reduced to something like maybe cos pi by 2 or something, which is not looking like the case. So probably we need to look at this very closely and see, can we write it in some form so that this become negative or something. So let's say I write it as cos of pi minus 3 pi by 13. So what I have done is I am looking at something 3 pi by 13 is there, this is 10 pi by 13. Can I write this like pi minus 3 pi by 13, because this will become 13 pi minus 3 pi by 13, which will be nothing but 10 pi by 13. And similarly, cos of minus 8 pi by 13. So cos of minus 8 pi by 13, first of all, you know that cos of minus theta is cos theta. So in this case, this cos of minus 8 pi by 13 would become what? It will become cos of 8 pi by 13. Once it has become cos of 8 pi by 13, can I write it as again cos of pi minus 5 pi by 13? Why? Because 13 pi minus 5 pi by 13 will be 8 pi by 13, right? So in one step itself, I just simplified both of the expression, and we are here with cos of 5 pi by 13 and 3 pi by 13. Now look at this cos pi minus 3 pi by 13. Now we know that cos of pi minus theta is minus of cos theta, so we'll write minus of cos of 3 pi by 13. Similarly, cos of pi minus theta is minus of cos theta, so I'll write minus cos of pi by 13 plus cos of 3 pi by 13 plus cos of pi by 13. Alright, so this one gets cancelled out, this one gets cancelled out, and we will be left with 0, and this is what RHS. So right, so when you observe this problem, you knew that this is looking a bit odd, so other parts are in plus but this is in multiplication. So you first look at this and then you see, okay, now we got to solve it because this is in multiplication. Probably this will come out in something in negative, so that it will cancel out, and this is how we started. That's why we solved this part first. Alright, hopefully this concept is clear. Let's move on to the next problem. Okay, my next problem has got something like sin 3x plus sin x into sin x plus cos 3x minus cos x into cos x equals to 0. So this is like an expression which is written like this. Probably first we need to write it like this: sin 3x plus sin x into sin x cos 3x minus cos x into cos x. Alright. So first of all, whatever is in bracket, let's expand and then simplify it. So we will get sin 3x into sin x, just expand it. Sin x into sin x will be sin square x plus cos 3x into cos x minus cos square x. So we have got expression wherein there is one term is in multiplication, one term is in square, another is in multiplication, another one is in x square, and when we look this one very closely, sin square and cos square x, it's looking like a formula which we know from earlier, which is like this: cos 2x is nothing but cos square x minus sin square x. So this is looking like that. So let's club other things together. So we have sin 3x into sin x plus cos 3x into cos x, and this is, if I take minus common, this will become cos square x minus sin square x. Alright. Now again look at this one. If I take this as A, take this as B, this becomes A, this becomes B. And this is a formula of sin A to sin B plus cos A into cos B. So basically this is nothing but a formula of cos A minus B. So cos A minus B would be what? Cos A is basically your cos A is 3x. So your formula becomes 3x minus x, and then this will become minus of cos 2x from here, cos of 2x. Now cos 3x minus x will become cos 2x again, and this will become cos 2x. Now both of them have become cos 2x, so it will cancel out and it will become 0, and this is what is RHS. So here as well, when you looked at the expression, something is in bracket, and then anyways looks like you got to expand it to get to some sort of combination, right? So that is why first we expanded it. When we expanded, something came in square, so we looked at it and then realized that it's a formula already, and then we clubbed other things together. We realized that okay, this is again a formula, and then we just simplified the formula and got the result. Alright, now coming to the third problem. Alright, look at the third problem. We have got LHS as cos x plus cos y whole square plus sin x minus sin y whole square. Alright. Now again, since this is the term in a square, first of all let's simplify it. Just simplify it. So we'll say cos square x. This is the formula for a plus b whole square. So we'll say a square plus b square plus 2 times a into b. So this is what we did. We just simplified it, cos square x plus cos square y plus 2 cos x cos y. Similarly, this is the formula for a minus b, so which is equal to a square sin square x plus b square sin square y minus 2 times sin a sin b minus 2 times sin x sin y. Alright, so now it's simplified. But while simplifying, I can also see that okay, there is something here, cos square x, sin square x, cos square y, sin square y. If I club it together, cos square x plus sin square x, this will become 1. Anyways, in the next step we'll do that. This one, cos square y plus sin square y will also become 1. Alright. And then we'll take, say, 2 common. Then we will have cos x, cos y minus sin x, sin y. Alright. Now this has become 1. This one has become 1. And this one has become 2 times. And again, this is a formula of cos x plus y. Right? We know cos x into cos y minus sin x into sin y. So this is a formula for 2 of cos of x plus y. Alright. Now we have got 2 plus 2 of cos of x plus y. If we take 2 common, what we will left with? Well, we left with 1 plus cos of x plus y. Alright. So this is simplified, but this is not what we expect on the right hand side. So then you also know that if it is something like 1 plus cos of 2 theta, then it will be nothing but 2 of cos square theta. Or rather, we know the value cos of 2 theta is 2 cos square theta minus 1. And looking like this is 1 plus cos theta, if I treat this as 2 theta, then this expression has become 1 plus cos 2 theta, and then the expression will reduce to 2 times cos square x plus y by 2. Because my 2 theta is x plus y, so my theta is going to be x plus y by 2. And this is what I have done. So 1 plus cos theta is equal to 2 cos square theta. So this has become 2 cos square x plus y by 2. So this will reduce to 4 of cos square x plus y by 2, and this is what we had to prove on the right hand side. So in all these problems, first of all, look at the expression and then try to simplify it. First, when you are going to open up the bracket and square it, some of the terms will eventually either get cancelled out or reduced to something manageable, and that's what has happened here. When we expanded it, we could club something from first bracket and then second bracket, right? Cos square x from first one and sin square x from the other one. We could club together, right? So this is what will happen in this miscellaneous exercise. There will be a lot of different concepts being used together. We'll have to make sure that we remember or whatever we have learned in the chapter so far. If we don't remember, we just go back to the chapter again and read through, or just go do the derivation or remember the formula, whatever is required. Alright. So hopefully problem number 1, 2, 3 are clear to you. If you have any questions, please ask me in the comment section below and I'll be happy to answer your queries. Thank you so much for watching this video. If you like my videos, please do subscribe to my channel and also post any queries or any suggestions which you have on my channel. Thank you so much for watching. Have a nice day.